Question 13 said a chemist needs 22 grams of phenol, which is C6H5OH. It's a special kind of hydrocarbon. For an experiment, how many moles of phenol is this? So the first thing to understand is that each one of these has 3 different types of atoms. There are 6 carbons, 5 hydrogens here, and 1, so a total of 6 hydrogens and 1 oxygen. So we can say 6 carbon, 6 hydrogen, and 1 oxygen. So 6 carbon would be 6 times 12 is 72 grams if I check my periodic table. 6 hydrogens is 6 grams, and 1 oxygen is about 16 grams. So 22 and 72 is 94 grams. So we can say for every 94 grams of phenol, there is 1 mole of phenol. And likewise, we can say for every 22 grams of phenol, there is blank moles of phenol. So 94 to 22, this number is getting smaller from 94 to 22, so that means this must be a number less than 1. Okay? This is going to be times 4.27, about 4. Divided by 4.27. So this is going to be divided by 4.27. And 1 divided by 4.27 is 0.23 moles of phenol. Okay, and our next question says, what is the total amount of moles of atoms in a jar that contains 2.41 times 10 to the 24th atoms of Cr, chromium, 1.51 times 10 to the 23rd atoms of nickel, and 3.01 times 10 to the 23rd atoms of copper. And we want to know question mark moles, right? So your first inclination might be to look this up on a web browser and say, oh, nickel. Okay, I'll look up the molar mass of nickel, or copper, let's say, which is right here. Pop that over there. And there's copper. And there it is. And check. It says, oh yeah, there's 64 or 63.5 grams. But you don't really need grams in this problem because the problem's not asking you anything about the grams. It's asking you only about the number of. So now we can change these statements to a forever statement. We can say there is blank moles of chromium. For every this many atoms of copper, there is blank moles of nickel. And for every 3 times 10 to the 23rd atoms of copper, there is blank moles of copper. And then we can just say for every 6 times 10 to the 23rd atoms of chromium, there is 1 mole of chromium. For every 6 times 10 to the 23rd atoms of nickel, there is 1 mole of nickel. And for every 6 times 10 to the 23rd atoms of copper, there is 1 mole copper. And then we can go in and solve each one of these problems, and we can say, okay, well, 6 to 2.41 But this is 10 to the 23rd, and this is 10 to the 24th. So it's getting bigger by 10 to the 1st. Times 10 to the 1st. But 6 to 2.4, well, 6 times would be 24. So I think if we just leave the times 10 and we just said this was times 4 and then move the decimal over, that would be 24. So this is 4 moles of chromium. This one, it's 10 to the 23rd and 10 to the 23rd, so it's dividing by 4. So this would be 0.25 moles of nickel. And this one is just halved, so this is divided by 2. This is divided by 2, so this is 0.5. So the answer here would be 4.75 moles of atoms.